Welcome to Modeling with Quadratic Functions. So this is your title for today. So what we're going to do, we're going to use what we've already learned about quadratic functions, about putting it in vertex form, finding vertex, and also looking at their roots and their intercepts to answer some questions. So the first question we have, an object is fired upward with an initial velocity of 112 feet per second. Its height in feet above the ground as a function of time in seconds since it was fired is given by the equation right here. So what I would do first is label what these things are. T is your time, and then our h of t here is the height. So that might help you figure some of these things out. So what it says first is, at what height was the object fired? So if we're looking at the height that it was fired, we are looking at, well, we are looking at a time 0. So if we put a 0 in for the t's, that would of course give me negative 16 times 0 squared plus 112 times 0. So then that means my height, my h of t, would just equal 0. So it started at 0 feet here. So next thing, we want to sketch a general curve of the equation. So if I'm looking at this, I have this equation here. The easiest thing to figure out a general curve is to look at its intercepts. So when we talk about intercepts, that's when we want to put a 0 here for the height. So 0 equals negative 16 t squared plus 112 t. Well, with an equation like this, I have a t in both of these, so I probably have a GCF. I'm checked to make sure to see if 16 went into 112, and it did. So my GCF here, I'm going to pull out a negative 16t. And so what's left here, if I take negative 16t squared divided by negative 16t, would give me t. And when I divided 112 divided by negative 16, I get a negative 7. So then what we do here, we set each of those equal to 0. So negative 16t equals 0, and t minus 7 equals 0. So I know my t equals 0, and my t equals 7. So if we remember, that tells me my roots or my x-intercepts. So when it says a general equation, I know I have one x-intercept here at 0, another one at 1, 2, 3, 4, 5, 6, 7. And if it's general, I know that it has to open down because the number in front of my t squared is negative, so I know it has to look something roughly like that. So it opens down, and these are my intercepts. So that's my graph. Now my next question here says, algebraically, find the time that the rocket reaches its greatest height and the maximum height. Label these on the graph that you drew in part B. So the maximum or the greatest height is going to happen at our vertex. So what I'd like to do is practice putting this equation that we have in vertex intercept form. So if we look at it here, I still have my h of t. If you remember, there is a number in front of that t squared, so I'm going to divide that negative 16 out of both of my terms. So I'd have t squared left minus 7t, leave my blank, and I don't have anything being added out here. If you remember, to complete the square, I have to take the b, which in this case is 7, divide by 2, which gives me 3.5, and then I have to square that, and that gives me 12.25. So I add in 12.25 here and have to figure out what I need to use to cancel it out over here. Please remember, since there's a number in front of the parentheses, I take 12.25 times the negative 16, and I get a 196. So it's like I added a negative 196, so to cancel it out, I put a plus 196. So to finish putting it in the vertex intercept form, negative 16, we need a factor. We know the first number here should be t. And what I want to do is, I'm sure you probably don't remember what we multiplied to get 12.25. So the easy thing is, we know it's a minus. If you remember, we had to divide this by 2. So 7 divided by 2 was 3.5, and that's what we squared. So your half b also always goes here. And that's going to help you out when you end up with some decimals that you had to add in to complete your square. So from this, our vertex, remember, change the sign of that number, so it'll be 3.5, comma, 196. So if we read this, we know that x is our time. So that means at 3.5 seconds, it went up at 196 feet. So 196 feet would be your maximum height. Last thing here, algebraically determine the time when the rocket reaches the ground. So when the rocket reaches the ground, remember that's going to be when your height is 0. If you remember, we found that up here in part B that we knew it was at 0, 0 where it started, and then it was at 7, 0. So how long did it take? Well, it ended up over here at 7, so that means 7 seconds. So this is where we could use intercepts to help find some answers to questions, and this is where we would have to use what they call optimization, finding a maximum and a minimum. So the next thing I want to talk about is using some technology in math. So here we have an exercise where we have a skateboard half pipe ramp, has a shape in the form of a parabola whose equation is given here, where x represents the horizontal distance across the 20-foot wide half pipe and y represents the ramp's height above the ground in feet. So with the help of your calculator, sketch a graph of the half pipe below. And it says label its height at its endpoints and its minimum point. So what we want to do is we want height at the endpoints and its minimum point. What I'm going to do now is show you a graphing calculator that I have online. And hopefully this shows up. And I'll show you how you can get this. You can get a graphing calculator, a free one, on most smartphones. But this is a free one that's online, and I can share this with you later in class. All you do is you type in the blank up here, the equation you want to graph. So in this case, our equation was, it already starts off with the y equals, so 0.06. Then I'm going to go over here and click x and then squared. Then minus 1.2. Then I go back over here and click x. And then plus 7. Once I click graph, it should show up. Now if we look, we can only see part of the half pipe. So what I want to do is I want to get my graph to move over. I only care about the part that where it crosses the y-axis. So I'm going to go to my settings. I'm going to change my x-axis, my y-axis. My x-axis, my minimum, I only need it at 0. My maximum, I'm going to estimate, we'll say, let's do 80. Well, let's do 50 and see if that's enough. My x-axis for this half pipe, I only need it to start at 0. And let's go ahead and end that at 50 as well. We're going to go over here and click graph. That's a little much on my x-axis over here. Actually, my y-axis as well. So I'm going to go ahead and make that a little bit smaller. We're going to go 30, and maybe my y-axis I only need like in here. So let's go ahead and do maybe 15 on that one. So if we take a look at this, my graph shows up. So what it wanted me to do was to come up with that minimum point. Well, I'm used to showing you guys how to do it algebraically, but you can actually find this using this graphing calculator. You can click a button, as soon as I get back to equations, that says trace. And so when it traces, you see a point come up over here. What I'm going to do is I'm going to go ahead, I'm going to arrow over, and I'm going to go down to its minimum point. So I can see the coordinate showing up down here. I see the y value at 1.24, 1.1, so it's gone down a little bit more, 1.1, 1.0. So it looks like my minimum is roughly, I think that's as small as I can get it. Well, yeah, so it looks like my minimum is going to be about 10. about 10.1, so I'm going to write that down here. And then it wanted where it started. So what we can do, I can keep airing over here. We said it was a 20-foot half pipe, so it would have to go 10 feet on each side. So I'm going to go over here. Since that was roughly 10, it shows us here when I'm on the y-axis, it intersects here at 0.7. And then if I arrow all the way over to a positive 10, actually should have been over at positive 20 is what I want to arrow over to. So I'm getting a positive 20 here. And it looks like it's about 20, and that's pretty much around 7 as well. So we're going to call it the point 27. So last thing I want us to do is draw a rough estimate of this graph. Ooh. So if I want to draw the graph, these are the points we came up with. And so when I draw the graph, I only needed the positive part. So we can put a dot here and label it 0.7. We had the half pipe almost go to the x-axis and then came up. So this lowest point was at 10.1 and this other endpoint was at 27. So it wanted to know label its height at the endpoints. The height then would be y, so it would have been 7 feet at the endpoints.